Good morning, everyone. This morning, I'll talk about an environmental compliance tool which we developed at the Army. And we thought this can be applied everywhere in the nation. And we are looking for a partner for this technology transfer. The title of this presentation is DOM, Digital Optical Methods. My name is Byung Kim. We are with Army Corps of Engineer Research Laboratory. Which one is forward? ERDC-CERL is a premier laboratory for the Army Corps of Engineers. We have so-called Army Research and Development user requirements. We talk to our Army installations and we ask them what kind of research we can do for you. One of the top priority research item was developing technology to monitor opacity from installation. EPA, as well as state agency, issued a permit to the air pollution sources or stack owners at installation. All the air permits require opacity measurements. Opacity means how opaque the plume is. For example, stationary point source, which is a stack, the owner of that stack is supposed to go out and look at the stack and see if there is any plume coming with opacity. So to meet these Army R&D requirements, we developed this DOM to address opacity measurements. Let's see how we measure opacity. The most common methods for opacity measurement is called Method 9, EPA Method 9. EPA Method 9 requires the air permit owner or operator go out and look at your stack and tell what % of opacity you are generating. It's kind of interesting. We see in 21st century, we still use our visual perception as the measurement tool. The problem with Method 9 is very subjective. That's why we have to go to the smoke school. At smoke school, we don't learn how to smoke. We look at the smoke, and you calibrate your eye to measure opacity. Because we use a visual perception, it's a kind of subjective measurements. It is also labor and capital cost intensive because people have to get training for certification of your visual perception. Also, you have to recertify your eye perception every 6 months at smoke school. In our DOM methods, we can expand beyond stationary point source. We can even measure the huge tip, PM plumes, particulate matter plumes. The second method to measure opacity is so-called transmissometer. We can install transmissometer in the stack and measure the opacity. But the problem is the installation cost is expensive. It costs about $5,000, but you have to maintain them. You have to clean the transmissometer very regularly. So it's a very expensive measurement method. The third method may be the LiDAR, which is $150 $100,000 or $150,000 equipment to measure plume. You know, we can measure accurately, but too expensive. So we developed this so-called DOM method, digital optical methods. I'll briefly tell you what is the strength of this method. It is low cost. We use regular digital camera, off-the-shelf camera, $100, $200 camera. We use that as our measurement method. We can do automatically, we can measure this. Then rather than subjective, it's objective because we have a picture and we analyze picture image. So it's a much more objective. And also, we can have consistent results. Also, not only we just look at it and you go to the court, said, I saw it, but we have a picture which we can archive. Yeah, we have this plume coming out, this stack. If we implement method 9 at all the stack owners, you think about how many stacks we have. For example, Alaska, they don't have a power generator. Okay, I'll do it. We have a lot of stacks, and we are supposed to measure it, and we can do that with this method 9. We had two.
You can only just tell them what booth you're at.
Okay, I'll do that. These are some of the tests we did, and what we are really looking for is a partner to do this DOM methods and commercialize. Our booth is 206, so I hope to see you there. Thank you.